Thank you for tuning in to Ellensburg Amplifier Repair and Service. Once again, I have a Type 4 Class D board that's labeled SXD18-1. I'm not sure if they're assuming that this is going to be an 1800 watt board or not, but as you probably have noticed throughout the videos, all these boards are the same. They use 640s on the output for the low side drive and the rail drive. So 1800 watts, I'm not sure. Maybe at a dead short. I'm not sure. So this board here has no power supply FETs when it came in. So I'm just probing around here, trying to see what we got going on. So I got my 12 volts on one side coming from the transformer, and then what you'll notice is I don't have 12 volts coming from the second transformer. I do have drive, but I do not have 12 volts. So the problem with this amplifier is obviously going to be a transformer problem. The strange thing is it's on both sides. So what I'll do is I will flip the board over. I will go through the traces on the bottom side and just check out what kind of connections I got going on the transformer, because I don't have anything coming from this transformer. Could be a shorted no, can't be a shorted transformer because my power supply is still running. So let me trace this one down and we will go from there. I'll be right back with you. Alright, so I'm just holding the 12 volt lines just temporarily in place on the positive and negative battery terminals here. So we do have, as you can see, I have 12 volts coming off the positive terminal. I have 12 volts at the first transformer, but I don't have 12 volts at the second transformer. So this just clearly tells me that there's a bus bar here going over to here, but as you can see, we have no connection coming from the bus bar. This transformer is responsible for all the control voltage going back to the Class D drive card to supply the voltage there. So this would be a reason, the primary reason why this board obviously is not functioning, because we do not have 12 volts going to the second transformer, which, like I said, is responsible for all your control voltage. So let me heat this area up here and dig for the bus bar. It probably has come loose from its solder joint. I'll flip it over here for you guys and show you what I'm talking about. So here's that 12 volt bus bar, goes down into this large via here, which should come up and go to this large heavily soldered trace here, which it is not. So I will go ahead and dig for that bus bar. I'll be right back with you again. Alright, so I have resoldered the bus bar here, and as you can see on the scope, we have 12 volts across the bus bar, and hopefully now I should have 12 volts on the transformer. And look, there we go. We now have 12 volts on the second transformer. So what I'll do is we got a little bit of carbonized board here. I'll have to clean up this carbonized board. Let me see if I can get you. Let me see if I can get this close up here of this carbonized board. Just to show you, if you're new to amplifier repair, this is something that you absolutely have to get rid of, is the carbonized areas of the board. This right here, I can kind of tell by the feel that it sounds like carbon. It doesn't sound like a full, solid board. It sounds crunchy. Well, that's burnt. That's going to be electrically conductive. So I will have to dig all that out. It's on both sides, and it goes down quite deep. So I may have a small board repair to do here. Otherwise, this transistor would fail, ultimately fail, if I were to put one in without taking care of that carbonized board. So just a couple things on this one. So first was just the bus bar that was not soldered in place. So I took care of that, and now I will take care of the carbonized board. So again, I'll be back with you. Okay, so as you can see, I'm digging out the area here that is burnt, and it does. This hole goes all the way through the board. So I will dig this out, and I kind of go by sound. I can tell by the sound that the tweezers make against the fiberglass of where I'm in good fiberglass versus burnt fiberglass. So what I'll do is I'll just separate these vias, and I will probably just do an epoxy barrier in between, and we'll get this put back together and fired up. Alright, so I have I've dug out the location of this transistor. It's kind of hard to see on the camera there, but it's all the way from the gate. Well, it's all three legs, the transistor here. There's probably a 1/4 inch by 1/8 inch hole here, all the way through the board. I did get rid of all the carbonized fiberglass. I did save the via going down to the 12 volts, and I did save the via coming from the gate resistor. So what I'm going to do is I'm going to pull the solder out of this, and I will get a transistor temporarily fitted in place, and then I will epoxy the hole. So alright, so I got the epoxy mixed and in place. So for you guys that use the pigment kits that I use, it's 3 drops of yellow to 1 drop of green to try to match the color of the fiberglass, not the trace, but the fiberglass. So it's kind of hard to see on the camera there, but I got it filled. I did save the via for the gate. Yeah, I just flip the board around every now and then, make sure you're not puddling up. This is a 5-minute epoxy, so it doesn't take too long, and I do put a tad bit extra B in to compensate for the pigment that I use. I only mix up a really small amount, and anyone that deals with epoxy knows the smaller amount that you use, the harder it is to get a good set. But I've done this enough times to know, kind of gauge how much epoxy to use and how much hardener to use. Otherwise, it looks like it turned out really well. I'm gonna let this set up for probably 15 minutes or so, and then what I do is I take my tweezers and I remove any excess epoxy around the traces where I'm going to be soldering to remove that epoxy. It's easiest to remove before it's fully cured. We'll get this power supply put together. We'll test the output. We'll test the Class D card. I do have one shorted 2X for sure on the output, but I'll show you that when we get to that point. So I will be back soon. I'm just going to let this epoxy set up a little bit, and we'll get this power supply running. I'll be right back with you. Alright, I've got the epoxy set up. I removed the transistor. From that area to let the epoxy finish setting up. I did put in 2 transistors per bank for each transformer so we can test the power supply section of this board. The rectifiers are installed, so it should build rail voltage. There's no output FETs, as you can see, so we're just gonna pulse this and see what we get. And it looks like we're getting some rail voltage here. Looks like we're doing good. So far, I do get a blue light. Let me just double check my rail voltages here. So we are 70 volts negative and we are 72 volts positive. Alright, so that's looking good. Alright, so we will move on to checking the Class D card, the output drives here. And just as a quick note, I temped in 3205s in the power supply. So let me change the view here for you. So we got our Class D drive card here, and we're going to test the pinouts. And again, here is the cheat sheet for the pinouts, so just to let you know. Pin 10 is going to be a drive, and pin 11 is going to be drive. So there's our pin 10 on the scope there, and our pin 11. So our drive at the card is looking good. So let's move on to the optocouplers here, and let's check our low side drive here, and you will see the low side drive at the optocoupler, and then the output of the optocoupler. Let me adjust the scope here so you can see this. And then we have the output of the optocoupler. So now let's check at the gate resistor. And we don't have drive at the gate resistor. So somewhere in here we're going to be losing our drive. Which it looks like I'm losing it right here at the very beginning, Q2. So, and I do have it circled, so I must this must be a shorted transistor. Let's go ahead and double check Q2 there, which is a 2X, and we're just going to verify and see what we, oh yeah, so Q2 is shorted, which is the reason why we're not getting our low side drive. So it's not detrimental to the optocoupler, so we're just going to move on. So we do have drive at the card, and now we're going to check drive at the optocoupler for the rail-to-rail drive. And it looks like we've got it at the optocoupler at the input, the LED side. And there's our transistor side. It's a little messier than I typically would like to see it, which is telling me probably we do have a faulty drive transistor. Oh, there it is. So looks like again we have another bad 2X transistor here. Yep, we sure do. So we do have more faulty 2X transistors. So what I'll do is replace the 2X transistors, and we will come back to this and double check the output drive once again. Alright, so I had to replace one more 2X transistor in the low side drive, so now I have the right amplitude of the drive signal for the low side. And the rail to rail is obviously still good. And again, this being squiggly like that, if you can see that on the screen there, is normal when the banks are not loaded up. So that's exactly what I'm looking for, are these particular drive waves, our negative and our rail to rail is good and ready for some 640Ns. So I'll get some 640Ns in and we will test that out, get some 50 Hertz into it, and see what our output looks like. Be right back again. Alright, I've got 640Ns installed in both the rail-to-rail side and the negative drive side. So we'll fire this up here and see if we've been successful at rebuilding the drive of this amplifier board. So blue light's on, it's powered up, and as you can see on the scope there, we do have our rail-to-rail drive. So I'm just going to double check the output terminal to make sure I don't have anything strange going on in the output. And I don't have anything completely abnormal going on. So what I'll do is I will hook up my 50 Hertz. So I power down the board and I will plug in my 50 Hertz signal here from my Heathkit IG 1272, and we will power this back up. Let me change views here. So I will power this board back up and make sure we are sustaining our drive. Make sure nothing's overheating. Please, I know I'm touching the back side of these FETs. I am not grounded anywhere, but there is high voltage on the back side of these 640s. So please don't attempt that if you've never worked on these boards before. I'd hate for anyone to get shocked. And these do pack a huge punch. So I was just quickly checking to make sure I wasn't getting any overheating situations on the 640s with that signal going in. Fire up the board and check our output drive on this. And as you can see, we do have output and it does look like we have a slight drive issue. Oh, yep. It's our negative rail here is heating up. So so let's see here. Alright, so what I've had to do is I had to replace the optocoupler and the 3 transistors, the 2T and the 2X's again, and I had to replace D1 and D3. They were leaking, so it was not making for a very stable low side drive. So and I have to rebuild the original drive card that came with it. So one of my drive cards is in it right now. So I've got the 50 Hertz signal hooked up to the amplifier, and well, now we should have a nice clean signal coming out. So I got 50 Hertz going in, and we've got our 50 Hertz nice clean signal coming out. Oh, and I also replaced the low side 5-volt regulator U1. Something was just giving me some bad feedback on that low side drive, so I had to go back through and kind of rebuild the low side drive section. But it's up and running. I got to rebuild the owner's original card, but otherwise this amplifier board is back up running, fully functional once again. I do thank you for watching. If you like this content, please like and subscribe. Give me a thumbs up. Any questions, concerns, or comments, leave them down below in the comment section. I will see you later.